In this animation, we'll be looking at how voltage gain and output voltage are calculated for the non-inverting operational amplifier circuit. Here we have the schematic symbol for a 5-terminal operational amplifier. This amplifier has 2 power terminals. In most cases, both positive and negative supply voltages will be used to power this device. The single output is capable of both sourcing and sinking current. This device also has 2 input terminals, the non-inverting input and the inverting input. These input terminals ideally have infinite input impedance. This would mean that no current will flow in or out of them. Another important characteristic of these 2 input terminals is that the voltage at the inverting input will be equal to the voltage at the non-inverting input. This will be true of all feedback type applications. Here we have the non-inverting amplifier circuit configuration. In addition to the op-amp, this circuit contains 2 resistors. The first is an input resistor Ri, and the second is a feedback resistor Rf. When an input voltage is applied to the non-inverting input, this input voltage also appears at the inverting input terminal. We will start our examination by assuming that a positive voltage has been applied to this circuit. The positive applied voltage value will appear at the inverting terminal, and current will be drawn up through resistor Ri. Since no current can enter the inverting terminal, the current is forced to flow through resistor Rf and into the output terminal of the op-amp. This results in a voltage drop polarity across the 2 resistors as shown here. As can be seen, the output voltage with respect to ground will be equal to the sum of VRI plus VRF. It will have the same polarity as the input applied. The same situation exists for a negative applied voltage, but the current flow direction will be reversed. When the negative applied voltage appears at the non-inverting terminal, current must flow through resistor Ri. As the current cannot come from the non-inverting terminal, it is drawn from the output and flows through the feedback resistor. This results in the voltage drop polarity for the 2 resistors as shown here. Once again, we can see that the output voltage with respect to ground will be the sum of the voltages VRI and VRF, and it will have the same polarity as the applied voltage. We can therefore conclude that the output voltage will be Vout equals VRI plus VRF for this type of circuit configuration. We also know that VRI will be equal to Vin, and that VRF could be expressed as IRF times RF. Because IRF is equal to IRI, we can express IRF as being Vin over Ri using Ohm's law. When we simplify this relationship further, we end up with an output voltage expression that is Vout equals Vin times 1 plus Rf over Ri for this non-inverting amplifier circuit configuration. We can now create the voltage gain expression for this circuit, as voltage gain is a ratio of output to input voltage. We simply substitute our output voltage expression into this gain relationship and reduce the resulting equation. This results in a voltage gain equation of AV equals 1 plus RF over Ri for this type of circuit configuration.